Okay, so if we look at 1.3, what I want to do is just use this as an opportunity to look at the cos graph and then explain a couple of concepts which make things a bit easier. Okay, so let's look at a cos graph. So our cos graph, we know that our sine and our cos, they alternate from 1 to -1. So our cos graph looks like that from 0 to 360, and it kind of goes like that. And okay. So this is why we know that it repeats every 360. What I want to do is look at the key points, which is there for me and there. And make, okay, so that's 360 degrees and that's -360. So the first thing to notice is this is if this is 0, then this is going to be, these are the same, right? So we see that if that's x and that's -x, we notice that we get the same value. So when we put cos 30 and cos -30 in our calculator, as we did in the last question, we saw that we get the same value. So it's just something to bear in mind. Cos x is equal to cos -x. So if someone gives you, if you have a simplification question and they give you cos -x, we can convert that to just cos x. Okay, so that's the first thing that the graph tells us. We see this lovely mirror image when we do the cos graph. The other thing we notice, it goes from 1 to -1. Okay, so that's the first thing. And it's because we're going to probably come back. Now, the cos squared x graph. Well, one of the things we must remember is that cos x when squared, I think I told you last time, is cos x squared. That's what that means. So it's sometimes better to think of this cos squared x as, because otherwise people often, they'll think that it's cos squared times x, because that's what it looks like. But how do you square cos? Because cos is just telling you that it's a ratio. Cos on its own is nothing. It's got to have the x with it, because it's you need to know the angle in order to work it out. Because cos could be anything. It depends on the angle. So that's why cos x is actually just cos x squared. So that helps us because it's saying that, well, if this is the cos graph here, this is the graph for cos x, then if I square any of these values, well, what happens if I square -1? I get +1. And so our cos x graph looks like this, but then our cos, let's draw a cos to the -x graph. Sorry, cos x squared graph. So this cos squared x, as I said, you can think of it as that. So any of these values just get squared. So what happens when I have the -1? -1 times -1, I end up getting 1. And so these values, these -1 values all become 1. 1 squared is just 1. Okay, now when I square a half, I get a quarter. So this value here actually gets smaller because a half squared is a quarter. So all of these values get smaller. And so I'm going to get like that. Now, when I square 0, 0 squared is still 0. So I get like that. Now, this value here ends up being up here. And so, you know, what we're going to end up with is sort of a graph that looks like. Now, the zeros all end up being in the same place. And the ones also end up being. So my points on the graph are here, 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 here. Here, here, So a cos graph, because it's squared, this squared graph, it always ends up being like that. Okay. Now the last thing is we don't have to know necessarily all of this, because we're just essentially solving an algebraic solution. But what this helps to us know is that we're always going to get a positive value. So this is by default positive. Okay, now let's just see how we would actually solve this. So the first thing I want to do is look at problem children. What is the problem child? Well, the problem child is the 4 to begin with. Okay, so if I divide through both sides by 4, the 4 goes away, and so then I'll end up with cos squared x over 2 plus 40 equals 3 over 4, which is fine. If this answer had been negative, you immediately, and you jump to here, as soon as you see that, to make sure, this question would be 2 marks, because it would be no solution, because you can't get a negative, as you've seen with this thing in orange. But because it's a 6-mark question, it's probably not going to be negative, and we see it isn't. It's 3 over 4. We're there now. What the orange graph, which is the cos squared graph, shows us is that we get a lot more solutions, a lot more positive solutions, because 3 over 4, the white graph is cos x. So if the question was cos x equals 3 over 4, where do we get 3 over 4? About here, here, and here. So you get 4. So every 360 degrees, you get 2 answers. But 3 over 4, when it's, notice the orange, it's positive 3 over 4 a lot many more times. We're going to get 4 answers for this. Okay. And that's, we'll see algebraically it's going to make sense. If I square root this cos squared x, because the next problem child for me is the squared. I don't like the squared because I can solve for cos x, but I don't know how to solve for cos squared x unless I square root it. So I get cos x, but now it's not cos x, it's cos x over 2 plus 40 equals, now because I've square rooted it, this is plus or minus 3 over 4. And this is what's going to give me my extra 2 answers. Because, well, we know what's minus 1 times minus 1? 1. What's 1 times 1? 1. So
are we only taking one answer here?
Hey?
Are we only taking one answer here?
We're going to take a lot. We're going to get, that's why it's 6 marks. Because we're going to get plus 3 over 4 and minus 3 over 4. So basically what we're saying is it's in every single quadrant.
Okay.
Because, okay, from 0 to 360, when we do it on a cast diagram like that, that's essentially 0 to 360. It just, the sine cos graph spreads out. So we end up having 4 solutions, right? 1 there, 1 there, 1 there. So we're going to get a solution in every single quadrant. Because we get plus or minus 3 over 4, the plus solution, oh wow, I wrote that cost diagram terribly. Cost, because it's plus or minus 3 over 4, the plus 3 over 4, which I've done, let's do a different color, yellow. That's going to be where cos is positive. So that's here and here. But then the minus 3 over 4 in purple says, oh, it's also where cos is minus. So we get 4 answers. So we're going to have to do every single quadrant here. Okay. So the way I would try to kind of simplify this for myself is if you just got cos x equals 1, or no, cos x equals 30, I would go, okay, it's positive. So it's in these two quadrants where I've done the yellow, and I do that. And I kind of know how to do that. Well, this is when you see the square thing, you know how to do the yellows individually, but also if cos was negative, you'd be able to do the purple individually. So now it's just more work. It's not harder work, it's just more work. Because now we have to do each quadrant. So that's what we're going to do. So the first one is just in the first quadrant is yellow, right? So that's where it is. We're going to have our reference angle is the first thing we want to do. So a reference angle tells us what the value is. The negative tells you the quadrant. How do I get the reference angle? From the 3/4. Let's do a different color. Let's do red. So reference angle is found by getting this. The plus and minus tell you the quadrants. The 3/4 is going to help us get the reference angle. So I put cos to the -1 of 3/4 to get my reference angle. So do you have any questions about the reference angle? Does that make sense? Do you want me to?
No. I think my metric work is slowly floating back into my head.
Yes. So 3/4 is the ratio. So cos an angle equals 3/4. So it's like if you're given the ratio that 3/4, that's why we need to find the angle. So it's almost like we're going back to that like a simple metric question would be to say, if they give you cos x equals 1/2, what is x? Well, to get x, we do cos to the -1/2. So that's what we're doing here. They're saying cos, except instead of the x, it's x minus 20 plus x/2 plus 40. But that's fine. We can deal with that once we know the reference angle. That's not a problem. This kind of becomes your angle. This x/20 plus 40 is your angle. Let's find out what that x plus 20/40 is in terms of an angle. So we say cos to the -1, 3/4. See if it works. No, it doesn't have to do it in like that. And I know that now the angle is 41.4. So my reference angle, because it equals 41.4. So if you know how we always draw our angles, so that's how I'm saying that this would be 41.4, this would be 41.44, and of course it's depending on what it's like 180 minus and all that. So the first quadrant, let's deal with quadrant 1. I'm going to make a little bit of space here for more writing. And for simplicity's sake, let's just do each quadrant individually. So let's do quadrant 1. And we'll do that in yellow because it's quadrant 1. This is going to be our first solution. So in normal situation, I would say if this was an x, I would say x equals 41.4, but it's not, right? I have x over 2 plus 40 is equal to 41.4 plus the K360. Okay, so when they say general solution, if it's a cos or sine, that just means plus K360 to all our answers. And we do that at the point just after we found our reference angle. So we're kind of getting there. We plus K3. Now, if it's tan, it's what? Plus K. If it was tan, what do we say? K 180. Because remember, tan repeats every 180. So just be careful of that. If it's cos and sine, it's 360. If it's tan, it's 180. Tan, although it's a more complicated graph, is actually easier because it's just always just repeats every 180, which is nice. Whereas cos is an issue because we've got to find this one, and then there's also these other ones because it's sum ends up being 369. You'll see. So what I'm going to do, take the problem child over, which is the 40. By the way, just when I say problem child, I don't know if I went over this concept, but what I like to think of in maths is there are certain things that I understand. Like I know if I get cos x equals 30, that's fine. I can work out x. Okay, but what happens if I have 3 cos x equals 30? This is what I refer to as problem child. And
It's like a known unknown essentially that shouldn't be there.
yes, exactly. It's like you
If
look
that
at
makes
something
sense.
and you go, I would be able to do this if this problem child would get. And so it sounds a little bit cruel, but I'm always trying to get rid of the problem child. So like if I
No,
root x,
I figured.
yeah, if I get root x equals 4, problem child is this thing. How do I get rid of it? I square it. So when you hear me say problem child, it's like, what is stopping me and how am I going to get rid of the problem child? This is the problem child here at the moment, and then over 2. Now, I could get rid of the 2 problem child by timesing everything by 2. So sometimes it doesn't always matter what order you get rid of. There's a few problem children in here, but I'm going to get rid of the 40. That's the first problem child that goes away. And if he can just go to the other side and he's gone. So I'll have x over 2 equals 41 minus 40. Because then when that goes the other side, it becomes minus 40. Well, that's just 1.4. So I'm going to say 41. Now, I would normally do another step, but because I'm running out of space, I'm going to put the 1.4. I'm going to make this 1.4 plus K360. So the 40 has come off the 41.4 to give 1.4. Now my problem child is the 2. Well, I can just times everything by 2 and he goes away. Right, so x times 2. Let me just write it down. I'm timesing everything by 2. Get rid of the problem child. And so I get 2.8 plus K 720. Okay, so that's my first quadrant solution. 2 is going to be the same, but now the second quadrant is 180 minus. Right, so now let me do that one in purple. So quadrant 2 is the other solution. And that is, in this quadrant, we know that it's 180 minus theta. So it'll be 180 minus x over 2 plus 40 equals 41.4 plus K360. Once I've done the first one, it's slightly easier. But the only difference is instead of the x over 2 plus 40, it's 180 minus that x over 2 plus 40. So this here. Now what I just need to do is, because I dealt with this here, if you can think of that there, I just need to do this. Put a bracket around.
Okay.
Because otherwise I'm going to end up with a plus 4 that's going to be wrong. And so I get 180 minus x over 2 plus, minus 180 minus x over 2 minus 40 plus 41.4 plus K360. Okay, so there should be an equals here. And so this is kind of just, I get a minus x over 2. 180 minus 40 is minus 140. Sorry, 140, but when it goes over, it becomes minus 140. So what I'm going to do is just highlight the thing. So this, and this is technically just going to give me my answer. You know, those can all be added up. So 180 minus 40 is 140. But when it jumps to the other side, it becomes minus 140. So minus 140 plus 41.4. It's going to be probably 98.6 with the, let me just put that in my calculator. I want to make careless errors. So minus 140. So yeah, because once it jumps across, it becomes plus 41.4 minus 98.6. See, I made a mistake. But I use my calculator. Minus plus K360. Okay, and then I just times everything by minus 2 to get rid of this -2 problem child. So I get x equals minus 98.6 times minus 2 is 197.2 plus K720. Okay, then I do this third quadrant, which is where it's 180 plus. And so I get 180 plus x over 2 plus 40. Now I should really put this in brackets for consistency. But it's fine because it ends up, it's not gonna be affected because plus 40, it doesn't change. I put a plus there. Equals 41.4 plus K360. And so here I get 220, which becomes minus 220 when it goes to the side. So minus 220 plus 41.4. Minus 220 plus 41.4. And minus 178.6. So x over 2 equals minus 178.6 plus K360. So this is going to end up, it's actually okay. I just want to, so here we added this 180, this 40. When it went to the other side, it became minus 220, and then we added that to that. That's gave us this. And then we just times by 2. So x equals, and then this times 2. I can just times this by 2. And I get 357.2 plus K720. Okay, and then the final one is the 360 minus the one in yellow. Okay, so I'm going to have to make just a little bit more space here. So this one's in yellow, so this is the fourth quadrant one. Actually, I can go over this other question. We're only doing this one question. So here we have fourth quadrant, And this is the 360 minus theta quadrant. So we have 360 minus 41, sorry, minus x over 2 plus 40 equals 41.4 plus K360. Okay, now what we can do here is plus K360 and 360. Well, plus K360 is like saying, you know, this is an integer K. So I could have plus 1, I could say plus 360. So these two technically cancel each other out. So to make
It'll just be plus K.
yes, good. So we end up, when we're dealing with this cos, we end up just saying that this so we get rid of the problem child straight away. So x over 2 plus so that becomes negative x over 2 minus 40 equals 41.4 plus K360. And so we have negative x over 2 equals negative 81.4 plus K360. And so we just times everything by 2, by minus 2. We have x over 2, sorry, just x, equals, when we times this by minus 2, we get 162.8 plus K 720. Okay, and that's that. That's done. Those are the general solutions. Okay, so 6 marks, a lot of work.
So we have quite a few general solutions.
Yes, exactly. The general solution, right? That there's no general. Well, there's no one general solution. But because we see that when we draw the graph, because they're saying, where is it 3 over 4? So if I'm going to use a different color that I haven't used before, light blue. You know, this is the y-axis. And so if this value is x, the y-axis is 3 over 4. So, you know, this alternates from, 1 to minus 1. So 3 over 4, if it's there in blue on the y-axis, if I go across, I find a solution here, and I find a solution here, and I find a solution here. I find one here. And then it just repeats every 360. Well, the way this x over 2 graph changes, I haven't really shown you how the graph shifts, but x over 2 means that it's like saying a half x. What that means is that your frequency is, you know how when we double to 720, so this becomes 720, right? So, it now repeats every 720 degrees. And so if this is 720, we have 4 solutions every 720 degrees rather than 360 degrees. That's what this does. I don't want to go into that and confuse you. If we get questions where we're looking at the tan solutions and its cos solutions, and they're giving us graphs, then we'll look more at the graphs and how 40 shifts the graph and how x over 2 affects it. But that's a whole other lesson. Okay, so I think we can. Are there any questions about that question?
No, I think I just need to go through more examples of that to completely get the hang of it, but I understand what's expected.
Cool. Okay, so I'm going to stop recording now.